Hello, everybody. It's me, Steve. Now, I had been trying to do this for a while. It took me a very long time to find this episode. I did do a longer version of this before I had watched it, and it was 3 hours. As you can see, this is an hour, 13 minutes. And I don't want to do a bunch of editing, so I am going to redo this. You can see my nice orange suspenders and skeleton shirt. I am in my recliner because this is rough. It's gonna be rough. All right. If you hear any meowing, I have cats and stuff. I'm not going to block that out. I'm going to try to stay focused. I'm going to try to stay on point. A lot of you know I can get very passionate and very animated, which was also a problem with the other video. I'm going to try not to swear. No guarantees. So I want to keep this as professional as possible. Those of you that know me know I'm a licensed professional geologist. My strengths are stratigraphy, structural geology, geochronology, specifically uranium lead. So there's still a lot of geology I don't know about. I am more of a generalist than a specialist, but that's fine because I think it helps me pick up stuff I don't readily see. If there's a topic on geology that I don't understand because I don't know everything, I will ask or I will just generally avoid it. You guys know I am a Precambrian, mostly Proterozoic geologist, a little Archean because sometimes they're side by side. So that's my specialty. You've seen me go through rock lectures, radiometric dating, all this stuff before. So we're going to use that to get into this episode. Evolution, factor, belief, geology, stratification, sedimentology. Now, I can already tell you from watching this that they run an experiment, but it takes them halfway through the video to even get to it. It takes them a third of the way through the video to even get to any geology. It's going to start with talking to people about evolution. This is a young Earth creationist video. All right. I will admit that. I'm going to skip over a lot. I'm going to stick to what I know. I'm going to assume the people in this are who they say they are. There's one guy in particular who's very sus, but I'm not going to call him a liar. I'm not going to call him a plant or any of that stuff because I don't know for sure. I originally thought this movie was 1993, but you're going to see the credits. I see it dated 2004. Now, I was recording video a lot higher quality than this in 2004. But, that doesn't mean the information's invalid. It just means I didn't try hard enough, I guess. But, there's been times I haven't tried too, so I'm not going to ding them on that. But it is an older video, so it's not going to be completely in focus. It seems to have a 1-to-1 ratio. I don't know why. I thought 4-to-3 was standard then. But anyway, as far as I can tell, this has no copyright. It took me a long time to find this video. I have seen it in the past, other than watching the whole thing recently. I have in the past seen clips of it. And that those clips used by young Earth creationists as some sort of point they think they're making. But anyway, let's get started with this. This is just the intro. I'm going to skip this. Okay, let's get into this a bit. I'm going to let it play a bit. As far as I can tell, this thing is not copyrighted, at least not anymore.
The countdown had begun. This costly space adventure was about
Okay, this is about the Viking 1, Viking 2. Let's just let him talk.
to swing into action to prove once and for all that given the right conditions, life could evolve from non-living matter.
But in science, we never prove absolutely anything to begin with. But even using that term generically. By the way, he's going to make up so many terms and misuse terms. I ripped my hair out the first time. Okay. But the goal was not to definitively prove life can come from non-life on another planet. And that's abiogenesis. That has nothing to do with evolution anyway, because in order to evolve, you need to exist. But let's just go.
The basic law of biology states that life can only come from life.
Hey, biologist friends, is that true? I don't know. I don't see why it would be. That doesn't make sense to me. Life can come only from life. I don't. It's kind of like a dog can only give birth to a dog type argument, which we've all heard so many times, which has nothing to do with anything.
Yet, now and again, some scientists suggest that perhaps life could come from non-life. In medieval times, for instance, the scientific world was convinced that vermin and flies were
Okay, I do know about this experiment coming up, and I'm just going to let it play because actually, from a simplistic standpoint, it's fine. And then I'm going to get into why I think they did this.
generated directly from rubbish dumps or garbage. In fact, the belief was so strong that in 1668,
Yeah, but that belief was also not based in evidence. It was an assumption based off a simple observation. That's the starting of a hypothesis. That's not a scientific theory. It's not how that happens.
celebrated Italian scientist Francesco Redi had to demonstrate by means of a simple experiment that vermin and
And this is a true experiment because it had an actual control. Those of you that don't know, I differentiate between experiment and demonstration. Demonstrations do not have controls. Experiments do, and demonstrations are usually just used to show some sort of point of something that's already been demonstrated to occur. But you can use it generically too. I don't really care.
flies breed in garbage, they don't come from it. He placed a piece of meat in 3 separate flasks.
That's probably because he had already made some observations that other people hadn't. And I know people like to sit there and think, well, why didn't anybody think of this sooner? I mean, everybody's got the same eyes. But when science was young, modern science was young, people relied more on hearsay and opinions of other people they trusted. This is the early days. Okay. So, if no one was going to really dig deeper, if everyone thought, flies came from a pile of shit, that shit breeds those flies. Guess I broke my swearing rule already. Why would they go any further? Remember, this is the early days of science, this modern science. There's no need to investigate.
The first flask was covered with a piece of thin cloth, the second with a piece of paper, and the third was left open to the air. Very soon, flies started to enter the open flask and settled on the decaying meat. Although the flies couldn't enter the flask covered with the cloth, they could smell the meat and settled on top. The one covered by paper blocked in the smell, and the flies ignored it. After some time, maggots appeared on the meat in the open flask. Maggots also appeared on the thin cloth covering the second flask. The decaying meat in the third flask, however, that was covered by paper, had no maggots on it.
That's fine. That's a good summary of that experiment.
It was then obvious to all the scientists that the flies had laid their eggs on the meat in the open flask, and that these had...
Now, they're going to get into, and I actually predicted this when I first watched it. They're going to get into spontaneous generation, and I'm going to skip all that.
hatched into maggots. As the flies could not get to the meat in the flask covered by the cloth, and could only smell it, they laid their eggs on the cloth. The flask covered with paper had no smell of meat, and so the flies were not attracted to it. This flask was free of maggots. 2 centuries later, however...
All right. This is where we get into the spontaneous generation. But the whole point of this was to set up and let you know that experiments work in science and that it's true. However, they have to be based on what we observe. The flask example there. People observe flies popping out of garbage. All right. Was it a reasonable hypothesis to assume that garbage produced the flies? Since they had zero knowledge base about reproduction of flies, yes, it's a viable hypothesis. And it was falsified by the flask hypothesis. Okay? So that's how science works. And then from there, they would go find the eggs, they look at the mag, they study the life cycle. That's how one simple experiment can lead to new, you know, frontiers. But it has to be applicable. At that time, the hypothesis that they just spontaneously popped out of garbage, or garbage produced them, or they hatched from eggs and became maggots were equally viable. Equally. Now it would be ridiculous if someone tried to go back to, oh, they must have come from shit. Because we have so much data to back us at this point that that does not happen. We even use maggots medically now because we know that doesn't happen. Okay? Can we absolutely definitively prove beyond a shadow, not I won't say shadow of a doubt, but 100 billion% now in eternity that our concept of fly life cycles is completely understood? No, we can't. But for all intents and purposes, we can. The proof and truth are not absolutes in science. Okay, that's not how it works. But, to keep conversations going with people who don't know what we're talking about, we'll say it. And towards each other, we'll say it too. Because we speak as lay people to other people. We all do that. My wife is not a professional geologist. She's learned some of the terms. But 6 years ago, if I would have told her, can you go see if the banded iron formation is on top of that marble or not, she would have no clue what I was talking about. She knows now. She's hung around me. But so when I'm talking to the average person who doesn't know, I might use geologic terms that I think people generally know, but if they don't, I'll soften it up. But I never dumb it down to the point where I'm talking to them as if they're 2 years old. All right, that's kind of insulting. That's just something I personally do, unless it is a 2-year-old, obviously. But that's just something I avoid. Okay, I'm going to skip the spontaneous generation part here. Just remember, your experiment has to be relevant to your observations. Like, I can sit there and model an experiment that shows a stop sign growing out of the ground. It means absolutely nothing, because never in the history of ever has a stop sign been shown to grow out of the ground. No matter how many mathematical models I produce that say, yeah, it does. We don't observe it. It's easily falsified. You got to come up with something else. You can't just keep beating at it. Oh, yeah, they do. Yeah, well, on the third night, they're in some sort of other dimension, and you can't see it unless you're looking at a specific... That's conspiracy crap, okay? So just remember, experiments have to be relevant to your hypothesis.
Belief by scientists in spontaneous life begets with dust or chemicals. On Earth,
Oh, this needs to be in a music video.
it was designed to scoop up soil, analyze it with its ultra-modern
Wow. I'm not being facetious when I say this. I love crappy animation, and this is perfect.
instruments and send the results back to Earth.
It's fine for the purpose of showing, but
Of one thing, the scientists felt sure. If life was not existing at present, it would have existed in the past.
yeah, I actually directly observed that. My grandmother, who's still alive at 94, gave birth to my mother, who's 70, who gave birth to me. Did I see this? No. But I have pictures, documentation, photos, family members who know and stuff like that. And I know that's how children are born. They come from a mother. So, you can't really use that argument for anything because past life, anyway.
There were indications that surface water had once been present on Mars.
Right.
And this would have created conditions similar to those that were believed to have originally existed on Earth.
Well, this is 20 years old, so we'll just move on.
Excited scientists could hardly wait to process the data that was pouring into mission control. Then came
Yeah, I bet that was true.
the shock. It was more like an immense disappointment, probably similar to that experienced by their ancestors at the time of Louis Pasteur's experiment.
What? I don't. Would they be upset if they didn't find life? Some guys might be, but they didn't go to Mars with the intention of finding life to disprove God. That's not how science works. The Viking went to Mars for numerous reasons. One was to see if there was life in the soil. There wasn't. Is that upsetting? Yeah, but it wasn't. So we move on. We don't sit there and I mean, some people sat there and said, sort of think maybe it's here, maybe it's there. I personally don't think they will ever find evidence of life on Mars, but that's my opinion. It is not fact, and I am not an interplanetary geologist, okay? But, it's they accepted it and they moved on. It's not like they shot up Viking 2 because they were upset about Viking 1's no life results. I mean, who thinks that way?
They had been so sure that life could be generated from non-living matter that it was almost unbelievable to find out that the Martian soil was sterile.
That's completely subjective. There's that's just, see that's the kind of thing we call leading language. Trying to put it in your head that scientists make mistakes, which we do, or our hypotheses are not do not come to fruition, which happens. But we don't sit there and kick over stuff and then beat it harder and harder. We try to find alternate explanations, hypotheses, or we just abandon it and move on. So this is, I don't even want to say it's a straw man. I try not to go into logical fallacies because everybody and their brother does it, and I just roll my eyes whenever I hear it. Because, the natural world is not beholden to our sense of logic anyway, so I use other wording. And other wording is going to be key in this episode.
Not only was there no sign of life, but there was no proof that life had ever existed in the past.
At the time. So?
They checked and rechecked the data. The story
Yeah, that's making sure you don't fuck it up.
was the same. In case they had missed something, a second mission had been organized.
Yeah, this basically gets into the whole thing that the goal of Viking 1 was to find life, and if they didn't, they shot up another one. Yeah, because that's efficient. Viking 1 and 2 were going to launch anyway, regardless of what was found.
The launch of Viking
So let's skip this dribble drabble.
2 on the 9th of interviewed who have researched various aspects of evolutionary theory to find
Evolution has nothing to do with stratification sedimentology. If Earth had not one living creature on it, not a one, rain would still fall, rivers would still flow, ocean tides would still come in and out, assuming we have the atmosphere we have. That it doesn't matter. Now we see this on other planetary bodies. Mars has windstorms. Aeolian wind-blown deposits are part of sedimentation, and they can form strata and stuff like that. So I go, wow, I had a major brain collapse there. So we observe on other planets these processes happening that, as far as we know, don't involve life at all.
out what the present position really is.
Now, I'm just going to tell you this. They only interview like 5 people. So I don't know how you sit there and say, draw a massive conclusion that evolution is false from 5 people. Like I said, I'm not going to question anyone's credentials in this, except there was one guy who's really sus, and we will get to him, because most of these people, I don't know anything what they're talking about. So I'm not going to do that. And yeah, are there probably a couple thousand that would swallow this as professional scientists? Maybe. But you're still talking less than 1%. And consensus in science is important. I know there's people that argue it's not, but those are usually the scientists with arts degrees, so we won't go there. But consensus is important because we come to consensus for a reason. We don't come to consensus because we all had a conference and said, the Bible's got to be false, guys. What can we do to make it false? That never happened. It's based on data. Now, the term, and he's going to say belief many times in applying to science. And belief has a couple definitions, but he frames it like it's a religious belief. When I say I believe in evolution, I don't mean as a religious belief. So we got to change our wording. What I mean is I have accepted the ability of the scientists in their field and the data I have seen to accept evolution. Yeah, it's a lot wonkier, but you can just say I've accepted the evidence. Something like that. Because words with multiple meanings are the creationist's dream. Okay? I mean, they love doing that because the more definitions a word has, the more you can confuse people. And that gets into big. He's going to make up words, or if he didn't make them up, the writers did. Somebody has something to do with this video, but we'll get to that when we get to that.
Really the case. Let's turn to the science which studies fossils, the science of paleontology. Professor Roberto Fondi is a specialist in paleontology. He teaches...
I just want to say something first. Creationists are notorious for taking things out of context and clipping things and stuff. I'm going to assume that's not what they're doing here. Just going to give them the benefit of the doubt. Like I'm giving the benefit of the doubt. These people are who they say they are. So, but we are going to skip this because I am not a paleontologist.
At the Department of Earth Sciences,
and should be folds of evolution mythology.
the study of the very essence and structure.
As somebody who knows what dog whistles are, it's things like evolutionary myths and stuff like that. Those are dog whistles, and that's leading language. I try not to do it, but I know I do. I swear instead of trying to do leading language, because to me that's far less damaging than giving a falsehood knowingly or unknowingly. And, but humans care more about, swearing than they do about misinformation because we're weird. Anyway, so let's move on.
Into the nucleus of the living cell. No one these days is more qualified to talk about whether one form of living organism could have changed into another than the biochemist.
Maybe the geneticist.
Professor Sermonti, a biochemist, geneticist, and molecular biologist of international repute, is just one of those scientists. So let's see what his views are.
I'm not a biochemist or a biologist, so we're going to skip this too. See, we're already 17 minutes into this thing, and we haven't even gotten to any geology. All right, finally get into it at 20 minutes and 45 seconds. Fresh.
One of the problems facing geologists today is the...
Okay, I'm just going to let you know about this just right up front so I'm not too lengthy about this. This picture he's showing you is zero context, zero scale. I don't know the location. I don't know what kind of rock this is. I'm going to give him the benefit of the doubt and say it's a legitimate picture. But other than that, he's drawing these frivolous conclusions from this picture. But assuming this is a real picture of rock, there are some things you can see. All right? But I'm going to address them. Let's get into it here because there's a lot of jibble-jabble here.
fossilized tree. There are a number of examples.
Yeah, he's going to get into polystrate fossils. Geologists don't use that term. That's a non-issue. He's going to completely give a misrepresentation of it, although he's going to show you a decent picture.
Australia and America and elsewhere, where a fossilized tree can be seen running vertically through a number of coal seams. Here's
Okay, we'll look at this.
an example from the coalfields of Birmingham in Alabama.
Okay, let's look at this. All right, at least we have a location. We have no scale. I am not a paleontologist. I don't know if this is a tree. I'll take his word for it. But since I have no scale, and just looking at what I know about sediments and pebbles and stuff, I'm willing to say this thing is 10, maybe 15 centimeters in height. But I don't know. That's not the 12 meters he's going to tell you. But let's move on. Let's keep this going.
United States. Some of these fossilized trees, 12 meters or more in height, can be seen
12 meters or more in height. And I looked at this picture. There's absolutely, and notice, I mean, yeah, the video's crappy quality, but this is the only thing he has. I have seen creationists call fracture patterns polystrate trees because they don't know what they're looking at. That's why you train as a geologist so you can recognize these things. That's why you got to get your butt up to the rock and look at the mineralogy of the rock, not just take a photograph from 100 meters away and go, oh, yeah, that's this then. It's not how real science is done. This looks like a fracture pattern to me, not a tree. How do I know that? Well, because I see other fracture patterns. This rock is very fractured. It could be cleavage too. I don't know. Okay, either or, it's fine in this case. Now, so fracturing is dominant in this rock. All right, and this is clearly more weathered than this is over here. Why that is, I don't know. Maybe this is a road cut. I don't know because I'm not given any context. See how frustrated I get? And these are legitimate frustrations. Okay?
Running through a number of banks.
We do not call anything a bank in geology unless we're talking about rivers. These are bed sets. Assuming this is sedimentary rock, which I can't tell if it's sandstone, limestone, shale. It's probably not shale, but because he doesn't say it, he just starts talking about it. There's no context background given. But bank is not something we say. These would be bed sets, and within them, let's just say his lines are correct. Within these colors, you see beds. Okay, beds make up bed sets. We know we can get planar cross beds too. So if you were to measure the trend, the orientation of this rock unit as a whole, you want the bed sets, not the individual beds if they were something like cross beds or something like that. Because measuring cross beds is just going to tell you the sediment came from a specific direction. You can't get the orientation of the unit as a whole. These concepts are key to picking out this bullshit. All right. So, I mean, these are just fractures in a weathered surface. So let's move on.
This model gives some idea of the situation. Now, the curious thing is that we are told that any one of these banks takes millions of years to form.
We're told that. This applying to this specific picture. Why do you think we're told? I don't know what rock unit this is. I don't know where this is at. I don't know the structural context. We know we can get relatively thick beds at a short amount of time. And bedding planes serve as kind of unconformities, usually of non-deposition, but it can be of slight erosion as well. But you can get clastic sediment deposits relatively quickly. We know this. It depends on the environment. Marine environments are most easily preserved, and they take longer to form. Terrestrial environments usually are subject to erosion, and all that sediment eventually ends up in the sea, okay, or ocean. However, we do have preservations like the Mid-Continent Rift. You guys have heard me talk about the Mid-Continent Rift ad nauseum. Lake Superior area, Copper Harbor Formation, which I broke out into members, 4 years ago now? Anyway, that is largely alluvial fan deposits, about a 1.09, we'll say, billion years old. It's a little less than that, but close enough. Now, based on, we have hard dates right below, in, and above. So we have the depositional time span narrowed down. And the Copper Harbor in places is well over 1,000 meters. Well over. Okay. So you would expect a marine deposit like that to maybe take millions of years. Definitely take millions of years, actually, of that thickness. However, the entire Copper Harbor Formation was a span about 9 million years, because it's a terrestrial alluvial fan deposit, because those cobbles and those boulders and that sand was being shed off highlands. As the Mid-Continent Rift failed, the basin subsided. As that basin subsided, what's going to happen? Land subsides, you got highlands here, the basin is subsiding, but not the highlands. You're going to shed sediment, and the faster that happens, the more and faster you can shed sediment upon. But that's a terrestrial environment. You have to let us know what you're talking about in context. But even if that was a polystreet tree, that would indicate to me that this was probably a delta or nearshore environment. This is not a marine environment because trees don't grow out in the middle of the ocean.
Now, if this was the case, it would take millions of years to bury the tree.
There's no tree there.
But that's not possible, because the tree would decompose or rot long before it was all buried. So, what is the explanation?
Just to let you guys know, I did try to find this guy, and I think I did find him. Pierre something is his name, and he's still alive, I think, but I cannot verify it's him. So I am just going to leave it out. You'll see his name at the end credits. I'm going to show you the end credits.
Well, a scientist has studied the problem, and the episode you're about to see will give you an idea.
A scientist has studied something. Yeah, I study something too, but I generally stay in my lane because I'm ignorant of vast majority of other things. And if I need to know something in physics or chemistry, well, physics I have pretty good understanding of, but like if I need to know something in biology, I'll ask a friggin' biologist. All right. And yeah, let's just get to it.
Of the implications of his startling but exciting discovery. Now, in order to understand the explanation, it's important to know the difference between a layer and a bank.
The difference between a layer and a bank is that we use the term layer and we don't use the term bank. And let's talk about a stream. Let me get off this eyesore.
The banks, these areas colored orange and yellow and bluish. In each bank, you can see a number of strata.
Yeah, beds.
What you can't see are the layers.
Bedding is layers. Beds are layers. Or lava flows stacked on each other are layers. Layers is a generic term in geology. It's not, it could be applied to different things. It could be applied to beds. It could be applied to lava flows. It could be applied to a lot of different things, even contact metamorphic zones. Okay? So the word layers is a generic, cheap term. And the term banks is bullshit. And let's just watch this.
Can't see them because as each layer of sediment arrived, it sorted itself out into the banks that you can see. If you could see them, they would look something like this.
All right. I actually called this. I'm like, what, is he going to see that weathering is something weird? And sure enough, here we go. I know people like to say absence of evidence is not evidence of absence. In hard science, it is. Because if you can't test it or observe it, reproduce it, it's garbage. I don't have to entertain it. That's the beauty of science. I don't have to entertain every idea, good, bad, middle ground, or otherwise. You know, if someone told me these were the piled up wings of dragons, I would blow them off. Obviously, there's no way to show that. All right? Now, what I want you to see here is basically he's going to show you what he means by this, but I just want you to look at this here. You see the beds? You can see they continue all the way through in places. All right? There's nothing here. In hard science, absence of evidence is evidence of absence. You can't just make stuff up to fit a model. We don't observe these anywhere. We don't observe it. We can ignore it. Plus, we know how marine sequences form.
After you've seen the film, you will understand why knowing the difference between a bank and a layer is so important. It not only provides the key to the fossil tree problem, but it also explains why the theory of evolution is crumbling.
Fossil trees have all to do with evolution other than maybe the evolution of that tree. Yes, we're back.
And what's so important about those rocks? Well, they're not any old rocks.
You tell this guy's never spent a day in the field. I don't know, maybe the producers did this. But they put him in a public amphitheater, which I guess this was before they zoomed out. And he's wearing a shirt and tie and dress shoes. Has this guy ever even picked up a rock? It's a man-made structure in a suit. I'm sorry. I'm sorry. That doesn't mean what he's saying is necessarily invalid. It's just weird to me because when you do this with geologists, we're wearing t-shirts and boonie hats and probably smell bad. And yeah, anyway, move on.
They are made mostly of tiny grains of sediment.
Now, he's only going to address clastic sediments. What are those? Well, he doesn't explain them, but they're basically mechanically weathered rock. They're smaller chunks of large rock. Your boulders, your cobbles, even your sands and silts. But you can only break down a rock so much. I mean, quartz can only mechanically weather so small in surface conditions. Other rocks form through other chemicals or through other processes. We call mudstones clastic, but the actual clays that, because they are deposited by the same mechanisms as sand and boulders and everything. But shale, clay, that those grains are not rounded. They are usually flat, platey, and they are formed from the chemical weathering of feldspars from igneous rocks as an ultimate thing. So, but they get transported in the same way as sand would. But then we have limestone. And he's going to mention limestone and an outcrop, and then he's going to completely forget about it. Why? Because limestone is a problem for this. It's a huge problem. Even other than the fact that we know that we've run lab experiments to precipitate carbonates out of solution, and there's no way you're going to get 1,000 meters of carbonate rock in a year, which is when they think the flood took place. That aside, limestone crosses two sedimentary rock divisions, if you will, biologic and chemical, as I think banded iron formations might also be too. Biologic means they can be formed from piles of dead things, mostly made up of calcite, things like that. But you can get limestone to precipitate directly out of seawater, as most of the Precambrian ones probably were. We do see stromatolites on occasion, but not that often. So it's either or. So stuff limestones in a normal marine sequence along a level plane. If you just walk along the top of the seabed, you look down, generally what you're going to see is the shore. You're going to see sand, you're going to see mudstones, and then you're going to see carbonate rock. Now, carbonate rock can precipitate out of anywhere in that sea. It doesn't matter where. But the thing is, if you usually have clastic input like sands and silts and clays, that shuts off carbonate production. Usually. Unless there's some sort of turbid thing going on. So if you have carbonates being deposited, you probably don't have clastics. If you have clastics, you don't have carbonates. It's a general rule. All right. That's why we don't find carbonates in our nearshore sandstones. We do have carbonaceous sandstones. That is true. I'm not going to lie about that in any way, shape, or form. But I'm just saying, in a marine general transgressive, regressive textbook model thing, that's what happens.
They are called sedimentary rocks and cover 3/4 of all the land on Earth. And what's more, they were formed under the sea.
Most are. Yes, that's true. Most preserved sedimentary rocks are marine. But you guys know me, the Copper Harbor Formation, the Nunsuch, the Frida, the Jacobs Group, these are all terrestrial clastic deposits. So they can get preserved. I mean, there's a lot of young ones preserved, like lake bottoms and stuff like that, but you start going back millions, billions of years, those things have long since eroded. So, but they do happen. And, the classics and Big Continent Rift are about 1 billion years old. So they can get preserved, but that was a special preservation going on there.
When the sea level dropped and the sediments were exposed to the air, they dried out to become rocks.
What? I don't remember. No. Sediment becomes indurated into what most people think of as rock through processes of induration. Now, a wet clay, yeah, it gets hard when it dries out. But what happens when you pour water on it again? It gets sloppy. Okay? if I pour water on these rocks, I don't know, like in a rainstorm, are they going to revert to sediment instantly and swell? No, okay. Drying out of rocks is not an induration process. Sediment becomes indurated as those layers become buried with younger layers on top of them. In a marine setting, usually because that basin is subsiding. Whatever rate that is going to determine our sedimentation rate. And our source is going to determine the sediment that we get. So, like, even though we get sandstone, mudstone, limestone in a typical marine sequence, as if you're walking on the seafloor, if we don't have a source for our sand, we're not going to have sand. Okay, so there's exceptions to this. But this in no way is how sediment becomes rock. Do you think basalt on the sea bottom gets hardened only if the sea retreats? Come on, man. I mean, this is blatantly wrong. Wrong.
Look at this cliff face. It's divided into facies, sometimes called banks or
Okay, facies, I'm not going to get into the nuances of that, but that is a legitimate term we use in geology. We don't use banks, that's been established.
deposits. The sandstone deposit has
Okay, sandstone, that's the top.
been colored yellow. The deposit of clay, blue.
Mudstone. Okay, we're just going to accept this at face value.
And the limestone colored orange.
Limestone, he said limestone. You're never going to hear it again. Okay, this is a good one. Let me show you this here. A is just your rock that the stuff's getting deposited on. They have it marked as fluvial, but it could be granites, it could be basalt, it could be anything. It doesn't really matter. Then you have your beach, which is your sand, but you can have marine sands as well. Shore face, that's your mudstones. That's what this pattern means. Open shelf, that's your carbonates. That's what this symbol is. We're just going to use this because it shows a transgression and a regression. Okay, during a transgression, as the sea becomes deeper. Now, seas can deepen in many ways. Tidal surge, storm surge can do it, but these are not permanent long-term events. So some of you may be asking, well, what does raise sea level? Tectonics. As you get an orogeny mountain building event somewhere else, because Earth is not getting bigger, you have compression and crust crumpling, it has to extend somewhere else, thin, or become a little less thick, usually through bottom's extension a little. It won't necessarily form a rift, but a basin will form. It can also happen due to mantle convection and things like that. All right. And that's going to cause the sea, although net sea level ocean volumes haven't changed, your land is subsiding. So relative to the land, the sea is coming up upon the land. That's a transgression. The regression is the opposite. Either your basin is no longer subsiding, is completely filled. The basin starts uplifting for whatever reason. Compression happens in a different area. Now you got two zones, so it starts lifting. Ice age in the southern hemisphere, northern hemisphere, whatever, drops it. Then you get a specific reverse pattern. Well, I want you to see here. If I was to drill right here, what am I going to see? Limestone, mudstone, sandstone. That tells me I have a transgressive sequence. And wherever it's been deposited, I drill through, I'm going to see that. Now, if I did it right here, I know I'm about in the middle, right? Now, in a regressive sequence, I drill the same thing. What am I going to see? This is fluvial deposits. Let's go right here. I drill here. I see the opposite. Sandstone on top of mudstone on top of limestone. As before, we had limestone on top of mudstone on top of sandstone. Now, this has vertical exaggeration to it, okay? It does. So, but it's not given. It's just a conceptual model to show you. But he needs to have scale on his because he doesn't explain anything. See how there's all kinds of words on this? He's just showing pictures, all right? So that sequence he showed you is a regressive sequence. That's what that is.
Each deposit or bank is subdivided.
Bed. Deposit, yeah, fine.
Into strata.
Yes, strata is the appropriate term as well.
These horizontal lines of strata. To understand the incredible story, that this film has to tell, a closer look at the strata in the deposit is necessary.
The problems with this is, I'm not, other than the quality of bad image, the other major issue is this is just a drawing with out of context because he never told you where that outcrop was from. Now, I'm just going to fast forward. Now, let's listen to it.
They follow a pattern. The larger particles collect together in a line at the bottom, then the smaller ones gather on top.
That's a finding upward sequence in a marine sequences that is pretty typical of clastic rock. That happens, but it's not always this way. And even generally throughout a thick unit, you can see generally a finding upward sequence. Unless it's something like an alluvial fan, then you get coarsening upwards a lot of times. Like in the Copper Harbor conglomerate, Sandstone Falls members, notorious for that. Anyway, so this, assuming it has anything to do with the outcrop you showed, is typical finding upward. All right? I don't have a problem with this.
This pattern is repeated throughout the deposit. A break or joint can be seen between the top strata.
It's not what a joint is. A joint in geology has a total different meaning than that. Just say bedding plane.
In one deposit and the bottom strata in the deposit on top. These breaks are called stratification joints or bedding plane
That is not a term we use.
partings.
I'd rather you say partings than joint.
For some time now,
I'm going to show you what a joint is real quick, just to show you why it's bothering me so much, instead of, because it's not even close to what a joint physically is. Here we go. Nice. Over this real quick. Joint. These are fractures or cleavage or both. These are sets. You usually address one set that's parallel, another set that's parallel. You can usually have two sets of fractures. You can have 3, 4, it doesn't matter. All right, that aside, let's find that diagram. Okay, here we are. Let's do this. So now you know where my source is, and this is pretty good. Joint anatomy. Joint. This is a joint. See where it says joint? Now, this could be a bedding plane. It could be a fracture surface. This doesn't even have to be horizontal. It could be at an angle. It could be vertical. It doesn't matter. This is a cross section. So I am pointing at the screen. It's a cross section through a joint. And there's some great ones that were caused by, I think, were caused by people because it's a road cut up in the Espanola area that are in my Espanola Red Side Geography book. They're like textbook joints. Anyway, what is a joint? Think of it as a mini earthquake. We'll just say this is the ground surface. What happens during an earthquake? You get, this would be your origin or your focus. You get a break. Something happened. All right? And this would be your epicenter. But and your waves propagate out. P waves and S waves in this case because it's a solid. You can think of it that way. So what happens? Well, your waves propagate out until they hit something different. So what happens is you get your plume axis, which is going to radiate usually parallel to this surface, whatever that surface is, a fracture, bedding plane, whatever. Okay, I'm not going to get into tip lines or anything. But you see these plumose marks? They radiate from that plume. And then your ribs kind of follow compression, waves as they would go. And what happens here, this fringe face, these patterns are so cool. I love these. This forms because you have a rapid change in density as it approaches. Because remember, things move a lot faster. Vibrations, waves move a lot faster through solids than in the air. So it's going to suddenly slow down. So instead of getting a plumose mark, you get this radial fringe face. And on the top, you'll see them. This is how you can identify them. So you know there's a joint in here, even if it wasn't exposed. And what can cause this? Well, road cuts, hitting things hard from a point. Rock falling from way up high down can do it. Let's see what else can do it. An earthquake can form joints. Rock that fractures, but not just like, a fracture is when a rock splits, but there's no movement. Now it can fall down the cliff. That's fine. That's not a fault. Fault still maintains that plane. It breaks and maintains that plane and then moves, whatever way. Okay. These don't. However, a fracture can be induced by something. Freeze thaw can do it. But something else that can do it too is just some sort of compressional strength from somewhere, or let's do horizontal, comes in and does this, but instead of faulting it, it's just enough to snap the rock, if you will, causing little bits to form origins. Okay, let's get off that. Let's go back to this.
There's been a suspicion that these rocks contain a secret, which when discovered will change our ideas on the most important subject of all. How did mankind originate?
Nothing to do with mankind. Nothing. Unless you're looking in recent deposits.
One of the first sedimentary rock experts,
Okay, we're going to go through this. He's going to misrepresent this guy. We need to talk about something called vertical exaggeration.
lying side by side as he went from the coast out.
See, none of this has any scale. Is this vertically exaggerated? Is this a map view? Is this a cross section? It is a map view. I can tell that from how he's talking. But man, dude.
To the sea was the same as the sequence of banks that lay on top of each other.
Yeah, so that's an observation. Okay, but that only applies so far. This doesn't continue off into infinity.
In a downwards direction. He realized that the belief that the bank at the bottom was older than the one on top was wrong.
It's not wrong.
Quite obviously, all the banks, the one at the top, the one underneath, and the one at the bottom, were all still forming.
And these are going to get into it. You know, this is what you...
They were forming sideways.
The only time we get sideways deposition is in a crossbed, like in a delta environment, something like that. Or the leeway side of a dune, you know, sand dune, something like that. And I actually have footage of that. Anyway, well, that's a video for another time. But notice he's only talking about clastics. He never mentions limestones ever again when it applies to this, if at all. I don't remember. But see, this is clastic. So... and what's the vertical exaggeration here? I'm going to show you why vertical exaggeration is important. I fortunately did not delete it. Okay. Now, this is a cross-section of the Illinois Basin. That's what you're looking at right here. From Illinois, I'll just show you the map. It comes up. I think it's this one. Okay, this is where you're going to go to get this if you want. The front page shows you a map view of Illinois. This is the Illinois Basin. The Illinois Basin, or East Interior Basin, is a pretty large intercratonic basin. I just want to show you a general picture of it because you can't really see it in the bedrock map. All right, this is basically the area it covers, this green area. Now we do, like in here, you will have Cambrian deep here, but it's closer to the surface here. What bounds this basin is the Kankakee Arch here in Sandwich Fault Zone. Yes, there is a fault zone up there, but we think it's extinct, maybe. You have the Cincinnati Arch here, and down here you have the Pascola Arch, which is what cut this whole thing off. But during the Phanerozoic, this was a pretty good basin, especially in the Paleozoic. And we even have some Cretaceous river deposits over here. Sorry, no dinosaur bones. So, yeah. So that's the basin. Now let's get back to this here. You know, this is that B2B prime from the map. I think B2B prime. Let's see if I can look at it. I'm going to open it, but I'm not going to download it. Well, I want to give you context. Where's B2B prime? Where are your cross? Oh, okay, because it's not in there. The cross section, here's 8A, here's B2B. So B2B is, if we put that on the other map, on our bedrock map, I just expected it to be on the, but I actually own this map. That's what's sad, and I forgot. So our B2B prime is somewhere in here, okay? So it's a west to east cross section. This is not to scale. Why wouldn't it be to scale, Steve? Why wouldn't you want to do this to scale? Well, in areas of high deformation, you wouldn't. Notice it looks basin-y. It looks like a big depression. But these rocks, let's look at these here. I did the maths. It's roughly about a 20-time vertical exaggeration, plus or minus. Let's zoom in a little more, see if you can see it a little better. All right, so this is feet. This is meters, 300 meters, 15 kilometers, 10 miles. So that's basically it. You divide that by that, make sure you're not either doing meters or kilometers, you get about 20. So in order to represent, these are little reefs, by the way. So in order to understand just how much vertical exaggeration that is, I took this in Publisher and I went here. I'm not going to do it again, but format picture, size. I clicked these off. I divided this number by 20. I typed it in, and this is what I got. This is how much vertical exaggeration. What can you see here? You can't see anything. As a matter of fact, those look pretty level. Don't these geologic units look pretty flat and level? You can see some topography, but if you're standing right here and you took a core or whatever, or even walked around here, and this was all exposed, it's going to look pretty level and flat. You're probably not even going to be able to get it on your compass as any sort of significant dip. So scale matters. It really does.
So that part of the top bank was the same age as part of the bottom bank.
The only time that happens is in a crossbed. That would be your bedding plane in the place of a crossbed. But he's showing this because what he's trying to show you is the core stuff comes out first and then it gets finer and finer on some sort of weird high vertical exaggeration. And I actually called it when I was like this. I'm like, this does happen in a delta, but it's not like this either. All right. Sort of. Anyway, so I called it. When they get to it, I'll show you when we get there.
It didn't take Walter very long to work out what caused the banks to form sideways.
The particles of sediment coming into the sea from rivers, floods, and wind sort themselves according to their size. These larger particles.
It's not quite that simple. Obviously, you're going to have a river has a lot more velocity and energy in it than a near shore environment, but that near shore environment has a lot more energy than the middle of the ocean, and that has a lot more energy than the deep ocean. So obviously, if you can carry sand in suspended load, it's going to do it until the energy drops enough where you can, drop it out of that suspension and make it a posit. Now, if that velocity of that water changes, you could get either subaerial erosion or you can get further deposition. It all depends on what's going on. But, they're trying to show you the basics of this, if you will. But it's important to know this is not a simple process. And this is not limestone in his model.
Particles colored yellow stay near to the coast. The less heavy ones, colored blue, are washed out a little farther. Then the tiny sediments, the orange.
By the way, I don't know of any place right off the coast that's like this. If you take this tree for scale, 15 meters? That means this is probably 15 meters. I mean, if I adjusted for, in this case, to show you something, for vertical exaggeration, which this has to be vertically exaggerated. It has to. But if I comped and shrunk it, these lines right here are going to point this way, from bottom left to upper right. That's not how sediment works. Right? You don't deposit from out here inward. That's not how it works. Not from clastic sediment sourced from a terrestrial source.
Ones are carried out by the waves and currents even farther. It can be seen that the layers of new sediment are deposited side.
All right, we're going to skip this because he just keeps going with it.
By side. Part of the bank at the bottom.
The feature of these
This is also greatly vertically exaggerated. I just showed you a basin and what happens. You'd be hard-pressed to find a basin at this scale.
series of deposits, or
Okay,
such as those observed by the two Russian scientists,
whatever.
would seem to be the result of major changes in the level of the ocean.
Yeah, transgressions, regressions, which I've already explained what causes those.
Rising water level is called a transgression.
That's correct.
Falling water level is called a regression.
That is correct.
When the water rises or transgresses,
This is showing the water transgressing from the land to the basin instead of a sea here. And this sediment is going to crawl up this slope. So it's direct contradiction of what he even just showed. I don't know what this is. This is not observed.
as the result of tidal waves,
And even at a tidal wave, this does, what is
Sediments
this?
deposit parallel to the sloping sides of the ocean basin. The larger yellow particles depositing next to the slope. When the water level falls or regresses, the sediments deposit with the smallest particles, colored orange, next to the slope. Looking at former ocean basins, now
See? He just admitted that was supposed to model an ocean basin. Man, this is just sad.
filled in with sediments, the position of the deposits or facies indicate that the waters of the past must have risen and fallen time after time in fast succession. As sedimentologists would say,
Yeah, by big blobs of water moving over everything, apparently. No, it doesn't. We know what flood deposits look like, and tidal wave deposits, and debris flows, subaqueous debris flows. It does not form this. This is not observed.
transgressions followed by regressions seem to have occurred in cycles.
That's kind of misleading because cycles gives you the impression that you get the same thing over and over. Something happens, then it happens again. Then it starts at the beginning to the end, beginning to end. You know what a cycle is. You're not three. Sorry. That's not what happens because that would be reflected in the deposit. Sometimes you get a repeat of sediments because you might have a similar source area or whatever. But most of the time, that does not happen. We don't see, in a normal marine sequence, if we just take a core, we might, okay? But you get a regression. I just showed you that. You get the total reverse of the deposits that you see in a transgression. So that is not what happens. It's not cyclical like that. And a lot of marine deposits, that doesn't happen at all because you got other things going on in this basin. Like in the Illinois basin, you have the Sal anticline. That thing is huge. It's the largest structure in Illinois. And I've taken you it in videos before. And then in other places, you'll have deltas forming and you'll have carbonate banks and reefs. All mess with this. It's not this simple.
The different kinds of deposit are again the result.
I'm skipping this. It's giving me twitch eye as it is. Oh, is this his flood? All the oceans just move about the globe? Water moving at high velocities without any load in suspension is going to pick it up. And if you move it fast, continuously, over and over, it erodes. It doesn't deposit. Now, it's not going to be able to carry some things, no matter how fast it's moving. But then that's going to break its energy. It's going to lose energy. Could you guys produce one testable model? One.
A rock expert.
He does here kind of a little bit with this whole experiment thing, but it's easily falsified.
Was that Johannes Walter's discovery only explained coastal rocks, and that deep sea sediments were always formed by a layer of sediment forming on top of another, and that the layer on top is always younger than the layer underneath. In this cliff face, probably formed from deep sea sediments, the strata in the banks at the bottom are believed to be much older than the strata
in normal undeformed sequence of rock. We're going to review Steno's laws here real quick. This is okay. We will use this. He's talking about the law of superposition. And here it just says younger layers of rock sit atop older layers. Younger stratas up top, older stratas on bottom. That's just very simplistic, and that was kind of what Steno said, but Steno didn't understand a lot. Okay, and it still holds. A better description of Steno's law of superposition. This holds true in an undeformed sequence of superficially deposited rock units. This doesn't hit. Intrusions make this. Faults can mess this up. Anticlines, synclines. These beds can be flipped through an orogeny. All this stuff affects this. But if it's undeformed, this is what happens. Now, and why did I say just deposits and didn't say sediments? Because lavas follow the same pattern. Just go to the mid-continent rift. You'll see, they're deformed, but if you undeform them, they were level like the sedimentary intervening units for the most part. There's a little initial dip, maybe 5 degrees, but nothing really more than that. Nothing like this. Okay, that shows deformation. We don't deposit like this, at least not on a large scale. You can get crossbeds that do this, but that's human scale stuff. Unless it's sand dune, then it's probably elephant scale. But anyway, I digress. So this holds true. All right.
Strata up there in the top. The reason for this is that geologists believe that strata
There it is. Geologists believe we accept the evidence.
and layers are the same thing.
They are the same thing. Like I said, the term layers is generic, but you're going to use it differently here, which is fine. Let's see if you define it.
In the 1970s and 80s,
Oh, that's right. His layers are that leading edge stuff. Whatever. Which aren't actually observed, remind you.
several holes bored into the bottom of the Pacific Ocean by the Glomar Challenger vessel produced samples of sediment that showed Walter's discovery applied to the deep sea sediments just as well as coastal sediments.
So what does all this mean? Well, take what is considered to be the biggest, the widest, the deepest, the longest.
I predicted this too. We're going to go to the Grand Canyon. And this is the creationists go all. They love to extrapolate global events.
Canyon in the world. The Grand Canyon in the United States. The science.
He's not going to go through any actual stratigraphy here, which is surprisingly convenient. By that I mean, because if you knew the stratigraphy and you knew the rocks and everything, you wouldn't buy his BS.
Of the canyon display banks.
It's not a thing.
One on top of the other.
In the Phanerozoic, yes, but we have Precambrian deposits, which include metasedimentary rocks. They're 3 times thicker than a Phanerozoic, and they're deformed and fault-bounded. Good luck explaining those.
From the bottom of the mile-deep canyon to the top. Each bank is said to indicate an age in geological time. Yet, what we know from Johannes Walter's discovery and the Glomar
No, you misrepresented him and you gave no citations.
Challenger deep-sea borings
so
indicates
ignored.
that parts of different banks could be the same age. Nevertheless, there were still those who found this difficult to accept. But 2 recent events have occurred, however.
No, we didn't find it difficult to accept. We don't accept bullshit.
Which should remove all further doubts.
It doesn't, actually. And he's going to use Mount St. Helens here. I'm going to skip it, but no, I'm not. Let's watch. That eruption was 1980, for those of you that are too young.
In 1980, Mount St. Helens, a volcano in the United States, exploded.
Yeah, that's a catastrophe, so you're going to get deposits that reflect that. We know this. We know catastrophes happen. But that's a far cry from all the oceans of the earth deciding that they're going to randomly burn over all the continents. There's realism, and then there's just ridiculous extrapolation. And that's ridiculous extrapolation. But yeah, this is fine.
It flattened an extensive forest and caused a tidal wave in a large local lake.
I did do that. That's true.
Within hours, 600 feet of sediment had formed, which dried into rocks complete with strata.
Now, I don't know where this picture is, but this could be I think I see things in here that look like volcanic bombs and stuff, so this has to be ash, pyroclastic deposits, and this may even be a basalt flow. I don't know. But hardening the rocks, it's what I don't even know what he thinks a rock is, because I can guarantee you, if this is from that eruption, I could probably dig in it with my hands, or at least a really blunt shovel. Now, this is probably made up of rock fragments, and that's fine, but I could still break it up. That's not iteration, dude. So, I don't know what context this is in other than it's Mount St. Helens. So, I don't know. Let's go. Not to mention it's volcanic. Oh, that does look like a basalt floor. We have an old joke in geology, igneous on the way up, sedimentary on the way down. But we consider ash flows, debris flows, pyroclastic flows as generally as being volcanic, unless they're dominantly rip-ups of sedimentary rock.
Result of the explosion,
Generically.
huge amounts of mud flowed through the adjacent rocks and bored a canyon over 100 feet deep and 200 feet wide.
Actually, the water did that. And yeah, it had stuff in there, but whatever.
Now, it has always been believed that strata in rocks and canyons take millions of years to form. But both these geological formations
I guarantee you that canyon at Mount St. Helens looks absolutely nothing like the Grand Canyon.
were formed within several hours.
The other event took place in a laboratory. French sedimentologist Guy
Sieves. Spent many hours with those.
Berthaud discovered two immensely important facts. The first was that sand, flowing continuously, whether in a vacuum, in the air, or in the water, sorts itself out into alternating deposits of large and small particles that look like layers but are not layers.
Okay, this is what we got to address here. I don't know what context this is in. I don't know if this guy knows his stuff is being used for this. I have no idea. We're going to assume it is. I want you to look at this. Now, those of us that have settled sediment out into beakers or graduated cylinders or whatever know that, yeah, you do get things that look like bedding planes, and that's fine. But am I going to get, and I've done this to shake it up too. Generally, what you see is the coarsest stuff settles out first and the finest on the top. But what if I'm missing an interval of grain size? What if I don't have silt? Well, I'm not going to see a complete fining up sequence. I'm going to see fining up in the sand, and all of a sudden it's going to get to clay. That's going to form a bedding plane. I didn't have the silt in the middle there. So this doesn't show anything.
The second vital fact emerged.
See, look, we're about halfway through and we're finally getting to the experiment. I'm going to pick it up here a little bit.
During the program of experiment, grading of particles.
Now, I was saying back before that a delta environment, and then I saw this and I'm like, oh yeah, cross bedding, prograding delta, which means it's moving away from shore, so.
In strata was not just the result of layers of.
What do you see here, though? You see bedding planes. His layers that are conveniently, I hate when people do that, and I just do it. Conveniently not visible in the rock face.
Sediment piling up on top of each other, as had always been thought. The grading could simply be due to variations in the speed of the current when the particles were deposited.
Notice how fast that water is moving? All right, let's skip a little bit here.
A further startling one. This theory now has to be abandoned because of two new discoveries.
No, anyway, let's
The first was laboratory. It was found that when the sea level drops and the damp sediments are exposed to the air, breaks occur between some of the strata.
That's not how rock becomes indurated. These are basic concepts. Basic. So obviously the audience here is people who are already young Earth creationists and don't care about the evidence, or it's people on the fence because they don't understand enough. And look how long it's taking me. I'm skipping huge parts of this, and look how long it's taking me to get to this video. What's the old saying? A rumor can make it away around the world before the truth gets its pants on.
As part of the drying out process.
Whatever, dude. Whatever.
In the following document periods of time, figure amount.
And they don't even tell you what these rocks are. This could be a sandstone. It could not be. See how you get these. Could these be due to tectonic uplift? Yeah, but I think they're probably sand dunes. I think this is sand. But you're never told.
Principal features of sedimentary rocks include distinct stratas of relatively homogeneous material.
In dune environments, terrestrial dune environments, yeah, you would get that. Yeah, that's true. But that's one environment out of many we observe today.
Intermittent settling of coarse sands in black and fine sands in white is tested in the laboratory.
Fine, whatever, but why is that mixed?
Consider the
Okay, his equation is fine. I'm going to skip this. I'm not going to burden you guys with maths, except the 7 divided by 10s thing,
motion of a sphere,
which does confuse me.
7/10
Yeah, this part, I don't understand where that's derived from, but
the
maybe
product
it is.
of the
I'm
Particles
just going to
in
move
front
on.
of obstacles or surface perturbation therefore increases.
Consider a homogeneous mixture of coarse particles in black.
We actually observe this in conglomerates. Would be a matrix-supported conglomerate. You know, Parfrey's Glen in Wisconsin, the Copper Harbor conglomerate or formation. You know, we see that.
And small
See?
particles in between. When we set this mixture into
Specific gravity.
This has to do with how you shake things up. Like you shake up sand, you get the coarser, more massive particles moved to the top. I figured this out with cereal when I was a kid to get the toy up to the top, unless it was glued in there, put on the outside of the bag. But yeah, we know this. This is just something that happens through vibrations in homogeneous or semi-homogeneous materials. This doesn't really happen with things of different, specific gravities, if you will. And that's fine. This is all fine. And just that proves young Earth creationism absolutely not.
Motion surrounding the particles
Okay, this is in water, and here you see laminations forming, but here it's still jumbled. So, and another
led
thing
scientists
too,
to believe that lamination
sediment doesn't rain down from the sky, okay? I mean, volcanic ash can, but that's not the norm. So this doesn't prove what he thinks it
was
proves.
caused by periodic
This is not observed.
cycles of turbulence. When the same experiment is carried out in the air, the settling cone displays all the features of lamination through repetitive segregation. Moreover,
This has to do more with going past the angle of repose than anything else. This pile of sand's only stable to a certain angle here. What is that? I don't know. Maybe 35, 45 degrees, something like that. And then it's going to slump off. Well, what's going to slump off? You can see they're still divided. Dark, light, dark, light. This proves nothing. Also, sand doesn't fall from the sky, so who cares?
the laminae thickness
This is just all jumbled up. There's vague bedding seen, but
lamination develops without the presence of a surrounding fluid.
do you not know this doesn't look anything like the previous two?
Under submerged conditions, lamination also occurs during gradual aggradation of the bed under plain bed conditions. Here's the same lamination sequence in accelerated motion.
Yeah, as long as your material stays homogeneous, your water velocity is constant, that's what happens. But that's not nature, dude.
a typical delta sketched on the
Wow,
board.
he says delta.
At the initial time T1,
Who'da
the delta
thunk?
is comprised of 3 parts. The top
Not
set,
to mention, this
the
is
foreset,
potentially
and the
has
bottom
vertical
set slope.
exaggeration.
at initial time T1. Over time, the coarse particles
All right, and this is his model. That's fine to produce, but he says delta like 5 times.
rolling on the bed slide down the foreset slope of the delta.
And foreset's fine. I don't have a problem with that here. Foreset slope of a delta. This is what happens at a delta. Because you have fast-moving river water relatively, all of a sudden velocity drops when it hits that sea or ocean or large lake, whatever it is, and you get a delta fan. And so this is nothing unusual. This isn't showing what Pierre thinks it's showing.
And accumulate sequence time T2.
It's fine. You guys can always watch this if you want, but I got to keep this moving. You can even see the beds here. I'm just going to say bed instead of laminations because it's just a matter of scale.
This typical delta gradually progresses in the downstream direction.
He even said delta. So, dude, are you trying to tell us that deltas infinitely creep out into the middle of the ocean? Is that what you're trying to sell? Because they fucking don't. We know this just from pinging radar of it's called the continental shelf. That is not delta propagation out to the abyss. Oh my god. This guy's getting to me.
Particles in the middle.
And look, you see the crossbeds. I'm looking right at the crossbeds that don't show up in your outcrop.
The thickness of strata is determined by the changes in sediment transport that occur in non-uniform flow.
Yeah, fine, whatever.
Let's now consider two particles in the delta. Particle A in the upper strata and particle B in the lower strata. Particle A deposited at a time T1 before particle B. Particle B in the lower strata therefore deposited after particle A.
He's modeling a delta. Fine, let's move on.
A dried delta, viewed from the flume sidewalls,
Okay, so here you have dried sediment, right, dude?
displays clear stratification characteristics
Look at the crossbeds.
in terms of superposition of deposits with similar particle size distribution.
No crossbeds there.
A clear stratification
He just bombshelled himself. He just kicked himself in the nuts.
A dried delta, viewed from the flume sidewalls, displays clear stratification characteristics in terms of superposition of deposits with similar particle size distribution.
Look pretty frickin' level to me. Now we know the upper ones are delta. Just shot himself in the foot.
A cross-section is cut through
Look, oh, wait. I thought things became rock when they dried out, dude. If things become rock when they dry out, how's he able to cut that with a piece of wood?
the delta to examine the primary features of deposits of sediment mixtures carried out under steady flow.
How is he doing this not being completely
supply.
embarrassed? Is he that ignorant of geology? I mean, who... Oh, my God. Even if I was a young Earth creationist, just what I know about geology, I'd be embarrassed to do this. This is embarrassing.
The cross-section displays a clear superposition of strata of fine particles in white and coarse particles in black with clear lamination.
That each strata is younger than the one underneath it and older
We've
than the one
covered
above
this.
it.
Finding
And that all
upwards, who
points
cares?
of the same strata have the same age.
The stratification experiment invalidates these hypotheses because these strata are not identical to successive layers. Moreover, clear stratification is observed on the
Okay, he said observe, not absurd, I think. I don't know. But he could just be talking about his delta model. This is just a clip.
continuous supply of heterogeneous sand particles.
I mean, he may be a young Earth creationist, but I don't know.
Why is this important?
You just
Well,
cut him
quite
off.
simply,
Where's the
because
rest of
strata
it?
have been used to date
I need the context. I have questions.
sedimentary rocks and the fossils in them for over 100 years. And now, for the first time ever, there is experimental proof to show
That deltas form crossbeds? Because that's all you fucking showed.
how strata form. And it is quite
You can't extrapolate that's all how all strata forms. There's different sedimentary environments. And I've even mentioned limestone precipitating out of solution. So where the fuck is your limestone model? That's right, you don't have one because you know you can't do it that quickly. Maybe you don't. But if you don't, you need to crack open a Geo 101 book.
obvious that strata cannot be used to date either.
We relatively date strata beds based on fossils. And I do the Precambrian, so I don't have any. You have stromatolites, good luck figuring out a species by looking at them. I could get Younging direction because we have domal ones. We have a lot of mat ones and you can't. We have domal stromatolites. We have columnar ones. So, if I see the mound, that's up. That's younger. I know that. But that's about as good as I can get.
Fossils or rocks. In fact, the fossils in the bottom strata
Are buried in the same layer of influx of sediment arrives and they all get buried. Eventually, if no air gets
Okay. This, other than being ridiculously vertically exaggerating, ignoring bio and chemically deposited rocks themselves, and shown to be factually incorrect by a model showing cross beds that conveniently not visible at any rock outcrop at that scale. Yeah, if this would predict something, what would that predict? Let's put our thinking caps on for a second. How could I make a prediction with this? Basically, I should see something like this maybe down here. If we're getting that kind of influx, a whale down here and a trilobite up here. Have I ever seen that? No. This hydrological sorting is a concept I think they came out with after this, which is just equally as ridiculous. But that, you would get a jumble of different ages of flora and fauna. Not to mention, quickly, this stuff's going to be bulldozing trees. It's going to be bulldozing your ancient people's buildings. We don't see any of this in this stuff, right? That's what your global ocean coming over that's going to do. It's going to tear everything up and redeposit it somewhere else. So why don't I have ancient Joe's flute down here and, a trilobite up here? Why don't I have that? Or, a tree down here, and I don't know. This would demand that. This itself would, but it would demand I should see something like a whale down here and a trilobite up here. It would demand something like that. But you showed your whole ocean going over the whole planet. And what about our Precambrian sediments? What about those guys? How do they fit in your narrative? I've done this before with Eric Hoven's Grand Canyon video, and he alludes to putting Precambrian sediments into his flood model, but never actually does it or say it, which is really ambiguous and done to cause confusion.
to them, they could turn into fossils. Here,
skip the rest
laboratory, layers of incoming sediment have been
Notice you get these variations in beds with velocity changes and starting. You're getting an influx here. So you get very level beds here. Now, I know why this is, because that's where everything's coming in. It takes a while to get the propagation moving. But you're just dealing with sand-sized particles. Matter of fact, what do you say, 0.2 millimeters or 0.4? I think that's about, where the range of sand is, So, yeah, I don't
wrongly identified. As we have seen, however, and as we have shown in the laboratory, layers of incoming sediment have been wrongly identified as being strata. The scale of geological time and the chronological succession of fossils have been calculated on this mistaken belief that strata are successive layers of sediment. A single layer of sediment can sort itself out into parts of many strata. So the position of fossil...
I think this is a guy that's supposedly a sedimentologist. I'll just accept that he is.
in the rock strata could simply indicate the ecological zones of marine species.
This is probably the birth of hydrological sorting, but we need a model, man. We need a model. We already know what you showed with that experiment is a delta propagation, and I could see the crossbeds plain as day, which I don't observe in marine transgressions and regressions.
Stratigraphy, as interpreted by observable facts and experimental data, challenges the geological timescale and therefore evolution theory.
Oh my God.
How old is the Earth? Is it millions of years or just a few thousand years? And what does radiometric dating tell us?
Okay, we're going to skip most of that because there's one guy in particular I want to address. First of all, you know, the perceived young Earth creationist age is 6,000 or 10,000 years old is a far orders of magnitude, literally millions of orders different than what the evidence shows. If you were plus or minus a few million years, you know, or even 10 or 100, I could see you having a point. But you're off 4.5 billion plus years. That's a lot, man. They're not show even if sediments were shown to be able to be deposited quickly in a marine environment. That does not mean the Earth is 6,000 years old. That does not mean there was a global flood. That does not believe Genesis is word for word truth. That's not how it works. It just demonstrates it can happen quickly. And us geologists know we have catastrophic things. We have volcanoes. We have meteorite impacts. We have landslides. We have all sorts of things. Storms, those type of things.
About the age of rocks. The science of physical chemistry can throw some light on these questions. And Professor Edward Boudreau is a physical, inorganic chemist who teaches at a university in New Orleans, Louisiana, and he has studied these matters. So he should be able to help us. It is explained elsewhere in the program that the strata and the fossils in the
This
rock
is the guy, by the way.
can give no indication as to the age of those rocks. Can you tell us if there are any other methods by which the rocks of the strata can be dated? For example, by carbon-14 dating.
Young Earth creationists love their carbon-14 dating. That is an organic process. It can be influenced because obviously if you're not alive, you're not going to intake carbon-14. But if you are alive, you will. That doesn't happen with inorganic dating methods. So we're going to skip it and go to the uranium-lead part.
Let us a piece of wood, for example, measuring how much of it, as you know, virtually all
Fossils can't be dated by radioisotopes.
Okay, they're going to get into uranium lead, which is my bag. And this is the last thing I'm going to go on into any real length, I think.
Well, certainly not by carbon-14 with any degree of reliability.
Carbon-14 is only accurate to about 50,000 years on dead things. There's no dead things to do carbon-14 on in the Precambrian.
As you know, virtually all the fossils are found in sedimentary rocks. And because this type of rock
You can get fossils in ash beds too, but yeah, that's general fine.
rarely contains radioactive elements, the fossils have had to be dated by rock strata in which they are found.
And that's relative dating. You're not going to sit there, point to a trilobite and go, he died 375.2641 million years ago. You can't do that.
And as we know, the latest experiments show that rock strata give no indication of age. Other types of rocks, such as crystalline rocks, which do not contain fossils, and lava do sometimes contain radioactive elements.
Any igneous rock can contain these radioactive things that he's going to talk about. And actually, the coarser the igneous rock is, like a granite, as opposed to a rhyolite, it's going to yield larger crystals and better crystals that you can more accurately date.
And these isotopes are used to date them.
Can you tell us, in simple terms, how you date a fossil or rock with a radioisotope?
Well, you can only directly date undeformed, unmetamorphosed igneous units with uranium lead or any of these other methods. You cannot date a fossil. Zircons or badiolites, we're going to stick with zircons because they're both somewhat similar. Zircons are made of zirconium. Actually, let me bring it up. I'm just going to bring up the chemical formula for you. ZrSiO4. Badiolite's not much different. We're going to stick with zircon. So what happens is zircon can be substituted for uranium, and that is radioactive. The zircon itself is not. And it'll be mostly zircon, or zirconium. Sorry, I say zirconium. Zirconium is the element, zircon is the mineral. I flip them side to side. I'm sorry. But that's basically your chemical formula for zircon. We're going to just ignore beta-light because they work the same way.
Yes, let us take a radioactive element such as uranium. This element decays very slowly into a non-radioactive element, which is lead. Now, the rate of the decay can be measured in the laboratory. So by comparing what's left of the uranium element in the rock with the amount of decayed lead element that was formed, and knowing the rate of decay, an idea can be had of how long it has taken for the lead to form.
So, if
Oh, yeah, I forgot I did that. That's how interested I am in this.
half of the uranium has decayed into lead, and by knowing how long it takes for uranium to decay into lead,
yes,
you can tell the age of the rock.
That's the theory.
Why do you say theory?
Oh, here we go, alluding to theories as being guesses.
Surely if it's a process you can observe and measure, it must be a fact.
Here we go, applying facts are above theories.
Not at all. Look again at the diagram. You can see that there are a number of uranium particles, the orange ones, and a number of lead particles, the blue ones. Here we have to make three major assumptions. The first is that all of the lead particles were originally uranium particles.
Yes, and I will explain why that is. Because they're not randomly dispersed throughout the rock as individual atoms as sediment or something like that. They exist in crystals, like zircon. If you have uranium atoms, it's going to want to bond with that SiO4 as much as that zirconium wants to. And this is a high temperature mineral. Basically, once a zircon crystallizes, it's immortal. It can mechanically weather, and they often do, but it's stable. On the Earth's surface or close, it's ridiculously stable. All right, these aren't random uranium just spread out throughout the rock with some lead sprinkled in it. That's not what it is. It's in the crystal structure. It's in the lattice. It's in the bonds. Okay, I need to say this. So, you know what doesn't substitute for zirconium? Lead. It's a physical, chemical impossibility. It doesn't happen for many reasons, but the main one being lead is a low temperature. I mean, you guys know you can melt lead on a stove. That's an oversimplification of why it can't be done, but it's basically correct. All right? So any lead in this rock has to be from decay. You're not going to force lead into that lattice. I mean, so any lead has to be from radioactive decay. But the internal structure of that crystal, those atoms that make up that lattice, the uranium cannot be substituted for lead. The lead has to come through decay. It's just the physics of it.
But there is no reason to believe that there were not some lead particles in the rock when it was formed.
No one says there can't be lead in there. It's just that zircon's going to form first, and lead's not going to form any sort of mineral if it's even present. That lead's going to, down here, it's going to bind. Your magma's going to be really hot, and that lead's not going to bond to anything until it becomes cool. Bones reaction series. I mean, zircons aren't on there and lead isn't on there, but things crystallize in an order based on their chemistry of the magma or melt and, the temperature. This isn't just like, oh, lead can only be a solid at this low temperature, but I'm going to jam it into that crystal lattice at, 2,000 degrees centigrade, which most magmas aren't that hot, but you know what I mean.
You see, there is plenty of natural lead in rocks that doesn't come from uranium at all.
Yeah, but it's not in the crystals of zircons. So it doesn't matter. It's irrelevant. Most lead minerals form in sedimentary environments anyway.
Really?
Yes. Let us take the extreme case.
He's talking as if all these geochronologists have not realized that lead can be an igneous rock. This is why I question who this guy is. I know enough about uranium lead dating to be like, this is not right. This is like completely wrong.
If this rock contained radioactive uranium and no lead, then the lead that would appear as a consequence of uranium decay would be a fairly accurate measurement of the age of that rock.
Yeah, but it comes from the minerals inside that rock, not the rock itself. And like I said, it's the first thing, zircons are the first thing to crystallize when a magma or melt body starts to crystallize. So it's not just like it's floating in the rock, and that's completely the picture he's trying to paint. And that's wrong. It's just flat out right wrong. I said I wasn't going to call anyone a liar, but it's just flat out right incorrect. So either that guy isn't who he says he is, he can't be. Well, I guess he could be if he's never heard of geochronology, or that they're making stuff up. I,
Or to take a more likely situation, that at least some of the lead was in the rock when it was formed, then the age of the rock is much less than we are led to believe.
that would be a, let me get his face again. That would be a daughter enrichment in the zircon. If you have more lead, that's your, because uranium, the parent decays into the daughter, lead in this case. So if that happened, you would get a jamming of lead in there, right? And what would happen if you had a daughter enrichment? It's going to look older. That statement is correct. But there's no way to get that lead in there to do that. So it doesn't matter. The point is pointless. And that's not what we see. What we see when zircon can undergo metamorphic, here I'm going to show you zircon zoning, just to show you what I mean. Zircons can undergo metamorphism and heating and pressure, and you get parent enrichment, which makes them look younger. Let me just show you this here. I'll show you. Is this guy? Here we go. Come on, man. Oh. Okay, we're just going to go on this. All right, you see nanometers there. You can see a lot of these are zoned. You get what that means. You see different layers within the crystal. Some are not. Some are just massive. Now, when you're trying to get absolute date, you want to go dead center because that's going to have the least amount of recrystallization. But even a zircon under heat and pressure, what can happen is you can get lead freeing itself. Why? Because lead is a lot easier to get rid of in a lattice than uranium is. So you get a parent enrichment, which makes the rock look younger than it is, never older. That's only going to happen if you can jam that daughter element in there, which doesn't happen. So that indicates we've had a metamorphic event. So that's at that age, at that younger age. Because in order to metamorphose an igneous rock, the igneous rock has to exist. That's just, logic, common sense. I can't deform something that doesn't exist. So you're likely to get metamorphic ages from the outside and an absolute age. And that's why we have things, let's do the Concordia, and I'm not going to get into the meat of this, but this compensates for it. Okay. Our Concordia plots, let's just use this one. Okay. Basically, this is a diagram that filters that out. And of course, it's a bloody, okay. This is a curve. This is the theoretical observed curve in an uncontaminated sample. All right. And if your sample's completely uncontaminated, your plots should all be around here. But we get things like it's a discontinuity for all intents and purposes. But you'll get points that form more of a line. And that oldest intercept is the age of your rock. If it intercepts here, it's 4 billion. Okay. And the metamorphic events will be between there. That's it in a nutshell. Okay. So we have ways to compensate for this.
Then there's the matter of leaking out due to solubility. Could that happen? Most definitely.
How are you going to dissolve uranium stably bound to a zircon? Dude, that's like saying if I piss on a piece of quartz hard enough, I'm going to leach out the silicon and get free oxygen. It doesn't happen.
Salts of uranium and other radioactive elements are quite capable of dissolving in water. And
Yeah, not all of them though. Good luck. I want to see you dissolve a zircon in water. I want to see that. I'll give you $100. No, I'll give you $1,000 if you can do that. You know, just in ordinary surface temperature waters. Good luck dissolving that zircon. I want you to actually do that for me. And $1,000 is yours if you can.
therefore will be removed from the sample. So if the rock had been exposed to water for some period of time, such as during...
Water's not going to penetrate the crystal phases of a zircon. It's not water soluble. Yes, water's a hell of a solvent, but it can't dissolve everything, and it ain't going to dissolve no zircon. Zircons can only be mechanically wet.
During a flood, some of the uranium could have been washed out. This would mean
That's
that the
chemical
age
weathering,
ascribed to
dude.
the
And that assumes it's not in the crystalline structure of a zircon, which we don't use to date anyway.
rock would be much too great.
But surely there must be other radioactive material and elements which are more reliable than uranium.
Well,
There's about 24 ways to do this, and we're not going to get into all these other ones. I just need to say some of them are better than others. Our equipment's not there on a lot of them yet, and that's just a result of our technology. But if you get two that are essentially equal technology for pulling these dates, you're going to get similar dates, and we do. So why would two different, totally chemically different minerals give the same date if there's no basic governing laws of physics expressed in radioactive decay? The simple answer is you wouldn't.
there's radioactive thorium, and all the way erupted, and the lava which emerged from that eruption was submerged in water. It was subsequently dated by the potassium argon method.
Oh, he's talking about a Hawaiian lava flow, and here's the thing. You're not going to use potassium argon to date something that's 200 years old. It's not that accurate. It's precise, but it's not accurate. Those are two different concepts. And I'm just taking your word at it. How do I know that's not contaminated with detritus? That's the problem with like pyroclastic and ash flows, is you got to be careful with them because they can be contaminated with detrital. But with a pyroclastic flow, it's real easy. But, you know, you just said a lava unit in Hawaii that's 200 years
Really,
old.
it should have shown the age of the lava to be
Like I said, it's not that accurate.
about 200 years. The date recorded, however, was 22 million years. Obviously, the highly soluble potassium salt had leaked out of the...
Oh, God. We don't date salts.
sample and left it looking very old. Other samples
I'm done. Let's just move past this.
taken from hollow decay. So any natural without a
Poland can help us.
Oh, this
A good
guy's a
scientist
geneticist.
is one who,
I'm not a geneticist.
since scientists trust each other, science of genetics
Are making evolutionary trees. They include
This is funny. That's like grade 3. Even 20 years ago, this was grade 3. You're talking to adults, man. Give them some credit. Even if they're young Earth creationists, give them an inch, would ya? I've met some smart young Earth creationists and everything else. It's just they buy this stuff. I don't know why. Cognitive dissonance. I'm not a psychologist, but give them a little bit of credit that they're not 7.
the science.
This is telling here. This program was produced by an organization? No, a voluntary non-profit organization. I hate when the British do that. I'm so used to seeing a Z, it gives me twitch eye. Anyway, who funded this? Young Earth creationists love to accuse scientists of doing whatever their government grant wants them to do, yet you can trace the money and know where it came from, but they do this, and I'm not supposed to question it? Was it AIG? Was it Creation Ministries? I guarantee you it wasn't the National Science Foundation thing. Oh, don't accuse people of doing what you do. I'm just gonna, I think I'm just gonna save that for the future. That's a goal. That's fine. Whoever funded it, but obviously they don't care about the science. At least not when it comes to geology. It's not supported by science because we did it in big letters in our credits. Dun dun boom! These credits are worse than mine. Fact is not above a theory. It's how science works. Facts are basically, can be used two ways in science, and I wish we would break it out. In fact, it's basically a tidbit of information or data that's not in dispute. That's really all it is. All right? And a lot of people, when they're trying to communicate science communicators will say a theory is essentially a fact because they know the lay definition of fact. And we really should find a better term for that, in my opinion. Because whenever a scientist says that, the creationist comes back and go, aha, you said it was a fact, so it's above a theory, because in my head, I have layman terms, so I'm just going to apply them to your profession. So we got to think of something better. Perihelion. Like I said, I tried to look him up, and I think I found him, but I can't verify it. And if it is who I think it is, I do want to say he is a professor. But yeah, a lot of smart people do dumb things, and a lot of dumb people do smart things. This is what made me think it was 1993 until I watched the whole credits. I saw this, like, oh, 2002. Watching this, 93 again. 4, 5, 7, 2004. So the most recent date I, see, and being a logical person, and I said I was going to take this at face value. That means this has to be 2004 or newer. All right, everybody. Thanks for watching this with me. I'm sorry. It was painful. I'm going to cut it down. Anyway, I tried not to bash anybody. And before anyone comments about how do you know what young Earth creationists are thinking, because I've interacted with them enough to know what they do and say and to know what happens when I present certain things. So I'm not coming from nowhere with that. But I said I wasn't going to accuse anybody of anything, so I'm not going to. I'm not going to say anyone isn't who they were presented to be, although I have my suspicions they're not, but I can't verify that. So anyway, there's enough self-damage done in this video where I don't need to discredit anything other than the presentation. Anyway, that's it. If you have any questions or comments, please leave below. And I hope you learned something.